So we have dsd data squared equals to 2a squared 1 plus cos theta. All right. Now, if I want to integrate this one, that means you will have to find the 2a squared 1 plus cos theta in a squared form. Okay, in a perfect square form. So how do you change this one to the perfect square form? So you do it this way. You have to make use of the half angle formula. So that means you have 2a squared. Then 1 plus cos 2 theta actually gives you 2 cos squared half theta. Right? Double angle formula. Or you call it the half angle formula. Okay? So therefore now I have 4a squared and then cos squared theta over 2. So that means our ds is actually in the form of 2a cos theta over 2 d theta, right? So the arc length s is given by the integral of 2a cos half theta d theta. Now, when I want to find the limit, okay, actually you see that the curve starts from theta equals to 0. Then it will turn this way to the pole O at theta equals to pi. Then start from theta equals to pi, it will go to the initial line again at theta equals to 2 pi. So it will return to theta equals to 2 pi, okay, for this stage. Now, in order to find this, to make our life easier, actually, you just need to integrate the whole thing from 0 to pi. Then the whole thing times 2. That's the answer. Because it's actually reflected. Okay? So therefore, you can see that the yellow curve, and the white curve actually have the same length. That's why you take this one times 2. You get the answer already. Okay? So therefore, you have 4a. All these constants you move out. Then you integrate cos theta over 2. Cos theta over 2, if you integrate, you get sine theta over 2 divided by 1 over 2. Then you integrate from 0 to pi. Okay? So in this case, you have, okay, I try to simplify the numbers first, before I sub in the limits. Otherwise, a lot of things to write. So I would simplify first. So I have 8a. Then you integrate
Sorry, sir.
sine theta over 2. Yes, from 0 to pi.
Zahi is in the waiting room.
Okay, Leong Zhe Heng. All right. So now we continue. You sub in the limits. Therefore, you have 8a. You have sine pi over 2 minus sine 0. So basically, the answer is 8a. That is the answer for this one. Okay. So if no problem, then we move on to the next part. All right. Now, the next part that I would like to talk about is the surface area. Okay. So now we talk about the surface area. So I send you a file just now. So the file is something like this. Okay. So we look at this diagram. Right. Now, the area of surface of revolution about the x-axis, about the y-axis, it can also be y-axis. All right. So I will talk about the second case about the y-axis later, because the diagram that I show you here is actually a rotation of the curve about the x-axis. So in calculus, whenever we want to find the quantity of something, we always do cutting. We cut the whole diagram, the whole solid or something like that, into a lot of pieces with uniform length. All right. So in this case, how I cut them? I cut them into uniform width of delta S. So you see, I keep cutting, okay? I keep cutting from here. So I cut, okay? Each of them would have delta S, delta S, delta S. You see, the side here actually refers to the length of curve, isn't it? Therefore, I cut according to delta S, okay? So I take a particular ring, all right? Assuming that this one is hollow. So you take a particular ring. So this is a ring with the radius Y, and the height, or you can call it the width, is delta S. So in this case, you will see that the surface area of this ring, this is the surface area, the delta A, all right, is given by, now it looks like a cylinder. So you are now talking about the curved surface of the cylinder. So the delta A is given by 2 pi RH, okay? 2 pi RH, where R refers to the radius. So because it's rotated about the x-axis, y coordinate become the radius. And the width, or you can call it the height, the h in this case is delta S. So this is one particular ring. I have a lot of rings because I keep cutting from x equals to 0 up to x equals to x2, for example. Then I have to sum all these rings from x equals to 0 up to x equals to x2, all right? So assuming the last part here, this is x2, all right? So you have to sum the surface areas of all the rings here. And you have a lot of rings because delta S is very small. So when delta S is very small, I put the limit, okay? I impose the limit on the left-hand side and right-hand side. So I'm going to sum all the surface area, and therefore I would get 2 pi y delta S. And when you sum, right, you sum from x equals to x1 up to x equals to x2 in this case. Okay, and you set the limit of the delta S as thin as possible. So as thin as possible means delta S tends to 0. Therefore, the limit of the sum is actually defined as the integral. So the integral of 2 pi y ds, and you integrate from x1 to x2. Okay, now there's a question here. What is this ds? So all of you know that the ds got two different forms. It depends on whether the equation is defined in terms of Cartesian equation or parametric equation. That's why you got the two cases here. So the ds, you have two situations. If you are given the equation in Cartesian form, therefore you take the first one, square root of 1 plus dy dx squared dx, okay? And then if you are given the parametric equation, then you take the form square root of dx dt squared plus dy dt squared dt. All right, that's why it gives you the case one formula here. A equals to the integral of 2 pi y times the square root of 1 plus dy dx squared dx. And you integrate from x1 to x2. Then for the second type of equation given, parametric equation, then you integrate 2 pi y, then square root of the dx dt in the bracket squared plus dy dt in the bracket squared. So in this case, you integrate with respect to dt, and the limit would be in terms of t, right? So you use the t limit, t1 and t2. Okay, so that would give you the two situations. Now, this is talking about the area of surface of revolution about the x-axis. That means it's rotating this way. All right. Now, what happened when the curve is rotating this way, rotating about the y-axis? That would give us the case 2 here. So let's look at the case 2. You look at this curve at the bottom, right? Suppose that you integrate, suppose that you rotate the curve, therefore you see the blue curve given at the bottom. Okay, the blue curve is here. So now, because it's symmetrical about the y-axis, all right, and therefore you know that the x becomes the radius. Same thing, you're doing the same thing. You're cutting it horizontally. Okay, so you cut horizontally, then the x becomes the radius. And you see, the delta s is still the same. Delta s here, delta s. So the bottom one also another delta s. Then the bottom one another delta s. The bottom one another delta s. You keep cutting so that the length of curve is uniform, delta s. Okay, so that's why the formula changes to what? 2 pi x. So you see the difference is here, 2 pi x. Okay, so 2 pi x times the square root of 1 plus dy dx squared dx when you are given Cartesian form. And then if you have the parametric form, then you use 2 pi x square root of dx dt squared plus dy dt squared. Then you integrate with respect to dt. Now take note, if I give you the rotation of the curve is about the y-axis, you only change the formula to 2 pi x, that's it. All right, you still use the x1 limit, you still use the x2 limit, you still use the 1 plus dy dx squared dx, no change to that. You only change it to dx because you want to integrate with respect to dx, therefore you have to use the x limits here. Okay, so we will talk about the example later. So the first example that I would like to discuss with you is question number 7. Let's look at question 7. Okay, question number 7. Yeah, this is the one. Okay, 7b particularly. So now let's talk about 7b. The curve, I will talk about the Cartesian first, okay? I will talk about the Cartesian first. Or maybe we talk about, hold on. Okay, we talk about number 4 first. Okay, we talk about number 4 first. Number 4, I think we have the ds, number 4. Yeah. So this is question number 4. The curve C has equation. So let's look at the equation. You have x to the power of half. Okay, we start with number 4 first. Number 4. Okay. So the equation given there is y equals to x to the power of half, and then minus 1 over 3, and then x to the power of 3 over 2 plus lambda. Now, the limits given here is actually from 0 to 3. So you integrate from 0 to 3 later. The first part, to prove that the arc length is 2 root 3, we did this one some time ago. I think it's last week. So today we will just continue with the next part. The area of the surface generated when C is rotated through one revolution about the x-axis. Okay, so I want to find the S in terms of lambda. So in this case, what you do is you must get the dy dx. Okay, because you did it long ago, I don't think you remember what is your dy. I mean the ds, the expression for ds. So I will re-derive the whole thing. So you have 1 over 2 x to the power of negative half minus 1 over 3. Then you have 3 over 2. Then you have x to the power of half. You have the dy dx. Simplify this. You have half x to the power of negative half followed by minus half x to the power of half. So to derive the ds dx in the bracket squared, so what you do is you, you have to use 1 plus dy dx squared. All right. So when you do this one, dot, 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 I think you can guess what is the final answer. The final answer is half x to the power of negative half plus half x to the power of half squared. This is what you will get. All right. So the dot, 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 we did it long time ago. I think last week. So you try to derive it and you get this one. So therefore, you can say that the ds dx is actually equal to half x to the power of negative half plus half x to the power of half, because you get rid of the square. Now, by right, when you get rid of the square, you should have the modulus here. You should have the modulus. But why I ignore the modulus in this case? Because if you look at the limit given, the domain of x given here is x in between 0 to 3. So when x is in between 0 and 3, the values inside here, they are always positive. Okay, that's why I don't put the modulus. No need modulus in this case. Okay, so therefore I have ds equals to, you can just take out the half, then you have x to the power of negative half plus half taken out already. So you have x to the power of half dx. So this is the expression for ds. But in order to use the formula, we have y ds, because the whole thing is actually rotated about the x-axis. So you have to use y ds. Y is the radius. When it's rotated about the x-axis, y becomes the radius. So y ds means you have to take the y. Okay, so you have half, then x to the power of negative half plus x to the power of half multiplied by y. Y is x to the power of half minus 1 over 3 x to the power of 3 over 2 plus lambda dx. Okay, so you need to expand this one, you got no choice. So you expand one by one. So when you expand one by one, you have, okay, half as the constant, just put. So you have x power negative half times x power half, you get 1. X power negative half minus 1 over 3 x power 3 half would give you negative 1 over 3 x to the power of 3 over 2 minus 1 over 2 would give you power 1. So x power negative half plus lambda. So you get lambda x to the power of negative half. Then the next one you expand. X power half times x power half gives you positive x to the power of 1. Okay, power 1. Then you have x power half times minus 1 over 3 x power 3 over 2. That would give you negative 1 over 3 x to the power of 2. And the last one is lambda x to the power of half. Okay, so this is the expression for YDS. Therefore, how do you find the surface area? The surface area is given by 2 pi, then you integrate y ds from 0 to 3. So you put in the expression. So if you put in the expression, you get 2 pi times half, then the integral of whatever you have there. So you have 1 minus 1 over 3 plus x would give you 2 over 3 x. Then you have minus 1 over 3 x squared. Then you have plus lambda x power negative half plus lambda x power half. So you need to integrate this one with respect to x. So integration of this one, I don't think is a problem. So you cancel the 2 and this 2 here, and then you sub in the limits, blah, blah, blah. This one you do it yourself. I'm not interested. So therefore, the final answer is 3 pi plus 4 lambda pi root 3. Okay, so this is how you solve the problem. This is how you use the formula y ds. Okay, next. Now we can look at question number we can look at question number 7. All right, let's look at question number 7. Okay, so for question number 7b, particularly, we are now talking about b. Okay, so the curve C2 has equation y equals to 2 times square root of x plus 3. So the arc of C2 joining the point where x equals to 0 to the point x equals to 1. So you know you are going to integrate from 0 to 1. Is rotated through one complete revolution about the x-axis. So when this is rotated about the x-axis, y is the radius. So 7b. So 7b particularly. So you have y is equal to 2 times square root of x plus 3. So we try to find dy dx, which is given by, now this is equal to 2 times x plus 3 to the power of half. So you have 2 times half followed by x plus 3 to the power of negative half, followed by the differentiation of the bracket. But differentiation of the bracket is 1, so it's okay. So cancel the 2, cancel the 2. So you have the expression x plus 3 to the power of negative half. So now you want to find the expression for dx square. So you have 1 plus dy dx square. So you have 1 plus x plus 3 power negative 1. Okay. So power negative 1 means you have the negative half here looks like. So it should be negative. Okay. So you have x plus 3 plus 1 over x plus 3. So the answer is x plus 4 over x plus 3. Okay. So that is the expression for ds dx square. Therefore, you throw the square to the other side, like what I told you earlier. we only consider the positive lah, because it will be positive. So ds is equal to, you have square root of x plus 4 over x plus 3 dx. Now, because I'm talking about the rotation of graph with about the x-axis, so therefore I have to use y ds. So y ds means you have to use the expression for y, 2 times square root of x plus 3, multiplied by the ds that you obtained just now. So you have x plus 4 on top, x plus 3 at the bottom. Take note that the square root of x plus 3 can cancel out with the x plus 3 at the bottom. Therefore, you have 2 times x plus 4 to the power of half dx. So in other words, you need to differentiate, integrate this one. Therefore, the surface area is given by 2 pi y ds, which is given from 0 to where? Number 7. 0 to 1. All right, 0 to 1. So you integrate from 0 to 1, and therefore you have, this is 2 pi. Keep the 2 pi. Then you put in the y ds there, so you get 4 pi here. 4 pi, because the 2 multiplied by the 2. Then you integrate x plus 4 to the power of half dx. So therefore, what is this? This is equal to 4 pi, then multiply by, now you have to integrate the x plus 4 power half. Integrating this one, I don't think is an issue. So you have x plus 4 to the power of 3 over 2 divided by 3 over 2. So you need to sub in the limits from 0 to 1. Okay, so if you look at this, you have 8 pi over 3. You always simplify the number first, yeah? Then you sub in the limits. So you have 1 plus 4, which is 5, right? So you have 5 to the power of 3 over 2 minus, put 0 inside, so you get 4 to the power of 3 over 2. Now the rest is just simplifying, because this is a proof question. So I will just stop at this stage, and you should be able to get the answer for number 7, which is 8 pi over 3 times 5 root 5 minus 8. So you need to show how you get the 5 root 3, how you get the minus 8 in the bracket, because you can see that the factors outside are both the same. So both of them are the same, means you are on the right path. All right. So we continue with another question. All right. So this is question number 7. Then how much time left? Okay. I hope I can finish this question. Right. Let's look at the next question, which is sorry? What?
You can't see.
Can't see what?
The notes.
I share already, right?
But you are in Zoom.
Oh, you mean this page?
Yeah. Thank you.
Okay. So now the next question. Okay. I'm afraid later it will stop halfway. So I would end this one, then I will immediately continue with, or you need a 5-minute toilet break. I think we resume at 12:40 lah, 12:40. All right. Because I may need some time to talk about this example here. All right. So 12:40.